All right, number one, no calculator. Number one, some of these are calculator problems. Number one is not. How many radians are in 315 degrees? Pi over 180 equals something over 315. So then I can cross multiply. And remember, you're solving for x. So it's 315 pi over 180. And we're going to divide by maybe 5 to start with. Now, you will have access to a baby calculator. So I'm fine if you use your regular calculator now, but I want an exact answer. So I think that reduces to 7 pi over 4, but I might be wrong. Double check that. 315 divided by 180, is that 1.75? Yeah?
Yeah.
So 7 pi over 4 is our answer. All right, number 2, you need your big calculator for this one. 136 degrees, 12 minutes, 19 seconds is how many decimal degrees? So you remember what to do? 136 second angle degrees. Jack? Jack, you know Devon. Do you know Devon Slaughter?
Yes.
Okay. Devon is in my class also, and Devon has a special rule. It's called the Devon rule. You cannot turn around. Devon cannot turn around. And you know what happens when he turns around? He gets an infraction every single time.
I don't want the Devon.
Okay, well, you got it. You got it. Now it's called the Devon/Jack rule. So don't turn around. All right, so we got 136 and there's 12 second angle minutes. And then where do we get that seconds?
Second.
Alpha plus. Right. So you should have gotten 136.205 degrees. Got it? Find the radius of a circle in which a central angle of 1.4 creates an arc that is 38.6 inches long. No. If it were degrees, it would have a degree mark on it. That's 1.4 radians. Caitlin? Well, that's what we're going to do. How did we find arc length before?
Well, it's radius times radius.
Oh, stop right there. Radius times radians equals arc length. So the radius is 38.6 divided by 1.4. I think our radius is 27.571 inches. You good with that, folks? Okay, we're trying to clear out some fog, bring all this stuff back into focus, because we're going to be moving on today. The more 4.2. All right, four radians are how many degrees? You're going to do exactly what you did right here. Only what's your proportion going to look like? Pi over 180 equals?
X over 4. X over 4.
Is it x over 4 or 4 over x?
X over 4 over x. The degree number. X. Oh, degree. 4 over x.
4 over x. Because this is pi radians, 180 degrees. This is 4 radians, and I'm looking for the degrees.
Yep.
So pi x equals 720. Remember, you're solving for x. So 720 over pi degrees. That is not a very common number. I mean, it's not one you see a lot, but that is the answer, 720 over pi. Now we're gonna find the navigational angle. So I'm gonna set up my compass. Here's north and west. Looks like that's what's in this problem.
It's below northwest.
Here is northwest,
It's below.
and I want west northwest. So this is the one I want. Would everybody agree with that? You gotta be able to figure that out, folks. Is that okay? You're on the west side of the northwest line, and we want to know this angle. What's this one? 270.
225.
And then this is the 45-degree split, but I don't want the whole 45 degrees. I only want half of it. So 22 and a half. So 292.5. Is that okay with everybody? All right, number 6. Now remember, these are navigational angles. Now I'm going to draw an angle in standard position, which means I don't use those labels. In standard position, this is 0. This is where you start. Since the angle is negative, instead of going up and around, I'm going to go down and around. So here I go. Tell me when to stop. I'm going negative 190. So here I go.
Stop.
Those are awesome. You're exactly right. Why did we go that far? Because this would be 180, and I have to go a little bit past it. Good?
Great.
Great. Find degrees, minutes, seconds for 78.136. So 78.136. Second angle DMS. 78 degrees, 8 minutes, 9.6 seconds. How's that sound?
Great.
Great.
Hey, laws, what are we doing here?
Remember, I said this was an old paper I found, so they must have made me mad. I threw a logarithm on there. I don't know. Let's do it just for practice, but you won't have any logarithms on your quiz when you get around to taking it. So we have 2 log x 5, x minus 8, and I'm just going to say equals 6.
Yeah.
Because I know I need to move that 4 to the other side. Divide by 2. So log base 5, x minus 8 equals 3.
Yep. 5 to the third was x minus
And then we loop-de-loop. So 5 to the third equals x minus 8. 5 to the third is 125. So it looks like our answer is 133. Joe, why do you have a glazed look at your eye? Doesn't that look familiar?
I was just looking at that. I was just looking at the board.
All right, we good with that? I wanted to do that only because we just need to kind of put things together. Let's get our notes out now. And let's continue in 4.2. We're on number 4 now, and we're going to evaluate with our calculator. And we're going to round, we're on page 42. This happens to be section 4.2. And we're going to use our calculator to evaluate these. Now, you guys, this is such a simple thing, but it's such a big, big deal. Notice, problem A is secant 10 degrees. But problem D is cosine pi over 9. That isn't degrees, that is radians. So when I'm doing this on my calculator, I need to use that mode feature to tell my calculator, are you inputting degrees or are you inputting radians? Okay? So our calculators right now should be set in degrees. Let's double check. In mode, and make sure degrees is highlighted.
Yep.
All right, so now while it's in degrees, we're gonna do all of the degree problems. So we're gonna do problem A, that's a degree problem. What about B? Is that a degree problem?
Yeah.
How about C?
Yeah.
No. How about D?
No.
How about E?
Yes.
Yes. How about F?
No.
No. How do I know if it's a degree problem? It will have a degree mark. So I am gonna do all the degree problems right now, okay? Now, I see some of you typing away, I'm not sure what you're pressing, hopefully the right thing. We want the secant of 10. You do not have a secant button.
1 over cosine.
It's 1 over cosine.
Cosine.
So we cannot type secant 10. We have to type 1 over cosine 10. There is no other way to do it, don't even ask me. Can I press this button? No, you can't. No. It's 1 over cosine 10. So here we go. I'm gonna make sure I'm in degrees. 1 divided by cosine 10. You should get, we're doing, we're how many places? 10,000, so 4 decimal places.
1.0.
So you should get 1.0154.
Yep.
How do you type a cosine? Or excuse me, how do you type a secant? 1 divided by cosine. Okay, so you gotta know that. It's on your sheet, memorize it. Okay, tangent 2810. Do I have a tangent button?
Yeah.
Oh, perfect. So tangent 28 second angle degrees, 10 second angle minutes. Oh, it's 11, not 10, crap. All right, let me start, I have to do it again. Tangent 28 degrees, 11. Did you get 0.5358?
Yeah.
Perfect. Go ahead and do E. That was our last degree problem. Go ahead and type it in and tell me what you get.
0.773.
Did I hear 0.7738?
That's what I got.
Easy peasy, right? All right, now we gotta do the other 3. So we're gonna go back to mode, and we're gonna switch into radians. So highlight radians. And then we're gonna do cosecant, problem C, cosecant 5 pi over 16. Can you put a cosecant into your calculator?
No.
Not directly. How are we gonna type it in? 1 over.
Cosine.
So you are, not 1 over cosine,
Or
1
sine.
over sine. So you are literally going to type this, okay? Now, when you hit sine, parentheses are automatically gonna come up, right? So 1 divided by sine, 5 second pi divided by 16. Use your pi button. Your pi button is over there above your arrow button. Right up below your clear button is your pi button. Tell me what you got.
1.3639.
1.2027 is what you should have gotten. Now, if we typed this in correctly, and we didn't get the right answer, chances are you didn't change your calculator into radians. You gotta make sure you're in radians. So you're gonna go to mode. Did you change into radians?
I'm in degree. Oh, no, never mind.
Yes. All right, you try cosine pi over 9. Cosine pi divided by 9.
Can you get a negative?
Yep, yep, you can get negative answers. You can, some of the trig functions are negative. You might be thinking, how can that be? We'll figure it out. We'll What'd you get for cosine pi over 9? 0.9397?
Yeah.
And then the last one, how do we do cotangent 2? 1 divided by tangent 2.
Negative 0.4577.
Negative 0.4577. Right?
What is it?
Negative 0.4577. Now, one more time. How do I know if it's a degree problem? I'll see a degree mark.
Yeah.
Right? Okay. All right, number 5.
Do we switch our things back to?
There's an angle out there that apparently has a sine of 1/2. So I kind of want you to think back to the last thing we did yesterday. We had a triangle that looked like this. Right? Now, I have been told that the sine is 1/2. What does that mean? Sine is, so opposite over hypotenuse. So opposite side is 1 and hypotenuse is 2. The other side is √3. Boys and girls, if you're doing this without a calculator, your triangle has to be special. And what special triangle has a 1 and a 2, a 30, 60, 90, right? Now, your job is to figure out what that angle is. What is that angle?
60. 30.
It's across from the 1.
30.
Across from the 1 is a 30. So your angle theta is 30 degrees. Now we gotta change that into radians. So let's be logical about this. Pi, a whole pi, is 180. 30 is what fraction of 180? 1/6. So if pi is 180, then 30 must be a 1/6 of pi. So it's pi over 6. If that just totally blew your mind, pi over 180 equals x over 30. And you'll get pi over 6. But I'm hoping that you won't have to do that with every single problem. All right, next one. Secant equals √2. Now, I always turn that into a fraction because my trig functions are all fractions. Think about it. SOHCAHTOA, they're all fractions. So the secant is √2 over 1. I'm 66 years old, I do this for a living, I love trigonometry, it's one of my favorite things, but I don't think in secants. When I see a secant, I automatically think of it as a cosine. You don't have to, there are people who don't, but for me, that's what I have to do, because I always think SOHCAHTOA. So if the cosine is 1 over √2, here's my picture. That means this is 1 adjacent, and this is √2.
45.
That's also gotta be a 1? which means this angle has to be 45 degrees. So the answer to the question is 45 degrees.
And then what, higher?
And then I figure out, okay, 45, I can either set up my ratio, my proportion here, or I can think, let's see, 90 is half a pi, 45 is half of that, so it's gonna be pi over. The more of this you do, the more that's going to make sense. Until then, you can always set up your proportion, press multiply and solve. All right, now we've got tangent equal to root 3 over 1. I'm gonna write it that way, root 3 over 1. So that means, here's my angle, that means opposite is root 3 and adjacent is 1. That's gotta be 2, because that completes my special triangle. What is across from the root 3? 60. So my answer is 60 degrees,
Pi over 3.
which is a third of pi, pi over 3, that's exactly it.
Wait, so
Huh?
do we have to have like the sides of the triangle memorized? Like it's like root 3, then you have to have like know like where like 2 goes.
Okay,
and
do you have your green
Yeah,
sheet?
yeah, I know it's like right here.
Okay, wait, what does it say at the top of the green sheet?
Memorized.
There we go,
Let's go.
there we go.
Let's get back on track.
All right, cosine equals 1/2. Cosine, so that's 1 and that's 2. And that's root 3, oh, whoa, same triangle?
Yeah.
So the angle is 60 degrees, which is pi over, 60 is pi over 3. 30 is pi over 6. 180. 180. You might think, well, wait a minute, are we always gonna get like 30 to 60? Yeah, we are. Because without a calculator, the only triangles you can do are those two. Right? If there's any other weird angle, we need a calculator, which is what happens in our next section. All right, we good with that? Pi over 3. Everybody keeping up?
Oh, yeah.
Last period of the day, we're almost done. All right, here we go. Number 6 says solve for the variable shown. Now, this clearly is not a special, there should be a perfect, oh, there is a perfect margin. This is not one of your special triangles, right?
No.
This is not a special triangle.
I'm gonna use calculator like. Here, use calc.
Since we're gonna need a calculator to do this.
Calc.
Now, I want you to look at the angle that we've got, which is 57.
90.
Now, you could find this angle,
33.
but I wanna just make us focus on what we're given. We're given that. With respect to that angle, which side is this?
32.
Opposite. Which side is this?
Hypotenuse.
Hypotenuse. So the adjacent side isn't part of this problem. Would you agree with that?
Yeah.
So I'm not worried about it. I'm only worried about the two sides that are in the problem and how they are relative to that angle. Now, since the two sides I have in my problem are opposite and hypotenuse, which function, sine, cosine, tangent, secant, cosecant, cotangent, will I use?
Sine.
Sine. Sine angle, so sine 57. What's the matter, Patton?
Nothing.
You sure?
Oh, yeah.
Okay, so sine 57 equals opposite over hypotenuse. Does that make sense to you?
Times 32.
No.
You
We're gonna
times
get
y.
rid of your fraction, so you times by y.
And divide by
So
sine.
y sine 57 equals 32. Get rid of your
Whoa.
fraction the way you have always gotten rid of your fraction. Multiply the denominator over. So y sine 57 equals 32. So y will equal 32 divided by sine 57. Before you type that in, that's a 57 degrees. Make sure your calculator is set in degrees, right? So we go back to mode, change our calculator back into degrees, and then 32 divided by sine 57. What'd you get? Tell me how to round. 100. 138.16?
It's not 4 digits.
Everybody okay with that?
156. It's 0.156.
156 to the nearest thousandth. This says hundredth, so I wrote it right to the hundredth, but yeah, whatever the rounding is, you got the right number. All right, now I got another problem, another situation. And this is 71, this is 18, and this is x. So you gotta pick a function. You're gonna write an equation. And I would suggest either sine, cosine, or tangent, because you have those on your calculator. So, which is this one gonna be? What's your angle? It's gonna be TOA. Because this is opposite and this is adjacent. So tangent 71 equals 18 over x. Is that okay with everybody? Is that okay? Now we have to solve it.
So move x.
So we're gonna multiply by x. And we're gonna divide by tan 71.
Can we always just like, instead of moving the x over, can we just automatically just move it over underneath the 18?
Yeah, you can skip steps if you want, just make sure you know what you're doing.
Just make sure it always does that.
Yeah. So I got 6.20 if I'm going to the 100. It would be 0.198 if I went to the 1,000. Okay? All right, now we got some word problems. Great way to finish our day with some word problems. All right, so what's going on? We got a squirrel sitting in the top of a tree. Stop right there. Here's the ground, here's the tree. We're gonna assume the tree is perpendicular, okay? Here's my squirrel sitting up here in the top of the tree. The tree is 52 feet tall. The squirrel is looking at a nut on the ground. So there's a nut down here. The squirrel is looking at the nut. His angle of depression is 23 degrees. Now, I want no confusion from anybody. I want you to listen to me. I'm the squirrel looking straight ahead. When I look down at the nut, that is my angle of depression. So your angle of depression is actually not even in the triangle. However, I know from geometry that that angle is the same as that one because of alternate interior. So every time you do an angle of elevation or depression, you're going to put it right here. They are the same. The angle of elevation and the angle of depression are the same every time. So put it right here, alternate interior. So put it right here, okay? Every time. How far is the nut from the base of the tree?
So we're using, wait, hold on.
There's the nut. There's the base of the tree,
Ten.
and that's X.
So we don't even have to find the top angle.
Nope.
Tangent.
So I'm gonna write an equation, I keep hearing tangent, because I have opposite and adjacent. So tan 23, remember the angle always goes with the function. So sine angle, cosine angle, tangent angle equals 52 over x. However many steps it takes me, I'm gonna end up with 52 over tan 23. So how far is that?
122.5. 50.
122.504 feet. In a word problem, be sure you're putting a U, oh, it says rounding it here is 100, so that would be 50. And in a word problem, be sure that you are putting on your. Okay, B. Now we got a seagull, and he's on top of a lighthouse. So, here's my lighthouse, here's my seagull. The gull, that's him, is 87 feet above sea level. So, there we go. He's looking at a fish out here in the water. This is the water. The gull, the seagull, is 230 feet from the fish. The seagull is 230 feet from the fish. That's 230. Don't make it hard. It's literal. Here's the seagull, here's the fish. How far apart are they? This, right? That's how far apart they are. What am I looking for? Find the angle of depression. That's right there. Remember, Mrs. Ford said, we're not messing. We're putting the angle of elevation and depression there every single time. No need for confusion, just put it there. All right, so what do we got? We got opposite, sine x. Remember, the angle goes with the sine. So sine x equals 87 over 230. To find an angle, we do the inverse sine. So if we know the sine and we want the angle, we press this very special button. So you see it. So you're going to press second sine, 87 divided by 230. And what's that angle? 22.23 degrees.
Wait, where'd that negative one come from?
It's the inverse sine notation. It's not a negative one. It's a button on your calculator. It's the inverse sine.
What?
You're gonna miss all this fun, Joe.
I know. Don't have me writing the answers. Don't have too much fun without it.
What? False.
Huh.
I wasn't even crazy.
So, guys, sometimes there's confusion. Mrs. Ford, do I use regular sine or do I use my inverse sine? And if you are looking for an angle, if your answer, if your x is an angle, then you're going to use your inverse. Tangent, cosine, whatever, you use any of them. If you know your angle, then you use the regular function. All right, see if you can draw a picture for C. I'll give you a hint. It's gonna look like all the other triangles we've drawn. Where's the 5,000 go? The plane is
Opposite.
5,000 feet above the ground. So isn't this gonna be 5,000?
Yes. Yep.
The angle of depression, always right here, is 17 degrees. How far is the plane
To the port.
from the port?
So.
Sine 17 equals 5,000 over x. Are you okay with that?
Oh.
Go ahead and solve it and tell me what you come up with.
17,101.52 feet.
I'm gonna type it in. 17101.52 feet, is that what you said?
Yeah.
Yep.
Shadow. Will be on the ground. Doesn't matter, it's angle, elevation, or depression. The same
They're
thing?
the same,
Okay.
they're the same. If you're the squirrel looking down at the net, or if you're a worm in the net looking up at the squirrel, same thing, same angle.
So you put in the same thing.
So always put it in the same spot. Then we never have to worry about getting in the wrong spot.
So it's. This year we prefer the opposite. We have that case out, so you prefer.
All right, D. Draw a picture, that's the key. If you can get your picture drawn, I'm pretty sure you can do you can get the right answer. Everybody put an X right here, there's the flagpole. Trying to hide the flagpole. The angle of elevation is 59, everybody put 59 there, I hope.
Yep.
Now we gotta put the 13 in there. Where are we putting the 13?
Opposite.
On the bottom. That is exactly right. Aiden's going like this. Why is he going like this? Because where do you see shadows?
Ground.
On the ground. The shadow's right down there on the ground. That's where the 13 goes. Perfect. So what function are you going to use? Tan. So tan 59 equals x over 13. This time, all you gotta do is times by 13. So 13 tan 59, 21.64. Is that not right?
Oh, 13 here. Why'd you have to divide?
Jake, I'm solving this equation right here. There's my equation. Tangent equals opposite over adjacent.
Oh, shoot.
That's what I'm saying, I don't know if it's, yeah, when you get from the base, from it, it doesn't say from the top, from the base. He's standing. He's standing on the ground, yeah.
Yeah.
Okay,
Oh, yeah,
next,
It was to say from the top.
last problem on this section. I got a man
Looking for angle, that's all.
looking at the top of the building. Have you noticed that every triangle you've drawn has looked the same?
Yeah.
Yeah, and that's how it is when you're doing angles of elevation and depression, they always look like this. All right. The building is 48 feet tall, and the man is standing 100 feet from the building.
So it's the boss.
I hear Jack going like this, I see Jack going like this, and Jack is right.
Now, if it
Jack
says,
is right.
if it said 100 feet from the top, would it
Yep,
be that
100
one?
feet from the top of the building, it would be here. But if you, if, I'm inside a building, but if I went outside and stood somewhere on the sidewalk and said, how far am I from the building? Wouldn't you count this off right here? This is the distance from the building. Don't overthink it. Don't overthink it. All right, sign, what am I looking for?
So,
I'm looking for the angle. All right, so this is gonna be a tangent.
negative.
It's reciprocal, right?
Inverse.
Inverse, yeah, pretty much.
Anytime you're looking for the angle, you're gonna do second tangent or inverse tangent of your number. So we use, are you erasing my numbers over there? Okay, good, thank you. Don't erase my numbers. So,
You wanna-
inverse tangent, 48 divided by 100.
It took her a while to do that, don't do that.
I didn't do it.
Oh,
The kid did it for me. Didn't I tell you that story?
that was.
I came in on the morning of March 14th,
Oh,
and that key doesn't work. So I have to use that back door. So I came in, it was dark. I come in the morning, got all my junk. And I used to have my AP sign on that board. And the first thing I noticed is my AP sign was moved. I'm thinking, what in the heck? And I turn on the light, and I look over. All that's magically written. One of my students snuck in and wrote all that
do we not know?
for Python. Yes, I do.
Why are the eights
Now,
underlined?
Okay, why are things underlined? That was my question. I couldn't figure it out. Turns out that was the way he was trying to communicate with me who did it. So the underlined things are the letters
In the
of
alphabet.
the alphabet.
Yeah.
Now, I didn't get that. I just knew from my students, I had an idea who did it, and I was.
Wow.
He's a clever feller.
He must be.
He's a clever feller.
One of my all-time favorites. And somebody said, when are you gonna race it? And I said, never. I'll retire and somebody else will race
What
it.
about like an April Fool's joke, like a senior prank?
25.64 degrees, is that what you got?
Yep.
25.64.
How long is that been up?
He just did it last year,
Oh.
so it's been up less than a year, actually. Okay,
We start 4.3 on that.
huh?
We start 4.3.
Yeah, we're in something.
Oh, great, should we?
Yeah, and next time we have class, which is what, Friday? We'll do a practice quiz over 4-1 and 4-2. So we just already did kind of a practice over 4-1. So I'll put something together over both, and then we'll have a quiz the next time, okay? Which will be Tuesday. Yeah. All right, I'll make you a deal. Let's get through number. Well, I got 2 A's and B's here. This is that top line of number 1. All right, let's get through that, and then I will be done for today. All right, so Elijah, you paying attention?
I was just talking about the horns.
Now, here is the new part. Up until this moment, every angle that we've considered has been in quadrant 1. Okay? Think about all the pictures that we've drawn, all the angles at the beginning of the period, I find 60 degrees, they've all been here in quadrant 1. This guy is not in quadrant 1. This is the point, -3, -4. And this big angle is my angle theta. And I need to find sine, cosine, tangent, just like I did yesterday, except I'm not quadrant 1. So what does that change? Well, let's see. I'm going to draw a triangle. So my perpendicular is going to go straight up to the x-axis. Now, boys and girls, when you draw a triangle, it's always sitting or hanging on the x-axis. Okay? I'm never gonna draw a triangle like this. That will be wrong. In trigonometry, we call it the butterfly bow tie. Your triangle will always be one of those. Sitting on the x-axis or hanging from it. Okay? So that's my picture. Now, if that's the point, here's the origin. If that's the point, -3, -4, does it make sense to you that I went left 3 and down 4 to get to that point? Can I do the Pythagorean theorem to find that?
Yeah, it's 3 -3 squared.
Well,
plus-
that, it's gonna be 9
Uh,
plus 16 equals c squared.
yes, ma'am.
Because they may be negative, but I'm squaring them, so they're positive. So 25 equals c squared, and it is 5, that's right. Now your angle is always right here, it's always at the origin, that's your point of reference, is always the origin. So this side would be opposite. This side would be adjacent, and this side would be hypotenuse. Now, why is the adjacent side negative? Because it is
Left side.
left of the origin. Why is the y side negative? Because it's below the origin. The hypotenuse is always positive.
That's all well.
The hypotenuse is always positive. X can be negative, Y can be negative, not hypotenuse. Okay, so answer the question, here we go. What's the sign? -4/5.
Actually, only said last time.
What's the cosine?
-3/5.
-3/5. What's the tangent?
-4/3.
-4/3, which is just going to be
4/3.
positive 4/3. And then these guys are still the reciprocals, so -5/4,
Yeah.
-5/3, and 3/4.
The negative just stay on top.
You put the negative anywhere, there's one negative, you put it on top or bottom or in the middle, it
These
doesn't
properties
matter.
are.
Okay? Now, Dana's question earlier was, can these things be negative? Can you get a negative tangent? And I said, yes. How can you get negative tangents or negative signs? Get out of quadrant 1. Because if you're not in quadrant 1, something's going to be negative, right? Not everything necessarily, but something's going to be negative. All right, I will stop there. Ooh, he is right. Aren't we excited?